Textbook exercise 1.5. The utility function is a quasi-linear utility function. The utility from Q1, Q2 is 2 times the square root of Q1 plus Q2. And we're tasked with finding the demand functions for the two goods. So what we want to find are D1 of P1, P2, Y, and D2 of P1, P2, and Y. So what we need to do is to solve this maximization problem. You want to maximize 2 times square root of Q1 plus Q2, which is your utility, subject to the constraint that P1 Q1 plus P2 Q2 equals Y. We're going to just substitute in Q2 equals Y minus P1 Q1 divided by P2 to turn this into a maximization problem of just one variable that doesn't have constraint. So we just end up with choose Q1 to maximize 2 times square root of Q1 plus Y divided by P2 minus P1 Q1 divided by P2. So we write down the first order condition. So we're just going to take the derivative with respect to Q1 and set that equal to 0. So the derivative of the first term is just going to be 2 times 1/2 1 over the square root of Q1. And its derivative of the second term is just going to be minus P1 over P2. And so the total derivative has to equal 0. That's the first order condition. We're going to solve that for Q1. So these 1/2 and 2 cancel out, and we add P1 over P2 to both sides. We get 1 over square root of Q1 equals P1 over P2. Take the reciprocal on both sides, square both sides, and you've got Q1. Now we can go back to the equation for Q2 and plug in the value of Q1 to find Q2. Remember, we've solved for Q1 already. Remember, Q1 is P2 over P1 squared. So that's just going to be Y over P2 minus P1 over P2 times P2 over P1 times P2 over P1. That guy cancels with that guy cancels with that. And so we have Y over P2 minus P2 over P1. Okay, we're not quite done yet. We found Q1 and Q2 and those are right, if the solution is an interior solution. So it's going to depend on Y. So what do we mean by interior solution? We mean that Q1 and Q2 both have to be non-negative. Of course, we found Q1 as being P1 divided by P2 squared. The prices are not going to be negative numbers. And even if they were, since we're squaring it, this is not going to be a negative number. So we don't have to worry about Q1 being negative. What about Q2? Could Q2 be negative? Well, yeah, if Y is small enough, Q2 would be negative. So Q2, which is Y divided by P2 minus P2 over P1, is going to be non-negative if and only if Y is at least as large as P2 squared divided by P1. So we have an interior solution if this is true, that Y is at least as big as P2 squared over P1. Corner solution otherwise. So the demand for good 1 is going to be the Q1 that we found on the previous slides if we have an interior solution. So if Y is at least as big as P2 squared divided by P1. Otherwise, we just spend all of our money on good 1. Similarly, if we have an interior solution, then the demand for good 2 is going to be the quantity that we found on the previous slide. Or if we have a corner solution, then it's going to be 0. So how do we know which of the two goods is going to be 0 in the case of a corner solution? Well, notice that if we have a corner solution, this is still going to be a positive amount, but this is going to be a negative number, and we can't have a negative number. That's not feasible. So that's why we know that it's good 2 that has to be on the boundary. So we have to have 0 quantity for good 2.